The sketch below shows the graphs of f of x and g of x, and you are given the domain. This is called the restricted domain, because you can draw the graph of sine and the graph of cosine from negative infinity up to positive infinity. But we want to draw these graphs from negative 180 degrees up to 180 degrees. And so you'll notice that f of x, the equation of f of x is not given in full. We do not know the value of a. And the equation of g of x is not also given in full, because we don't know the value of theta. But we are given the diagram there. And so we need to interpret that diagram. So this is called graph interpretation. The first question you can see there in your papers. The first question says, determine the period of f of x. So let's go back to that graph. It is the thinking process that I want. So remember, we want to test you for skills. So when we say we are not testing for content, it means I won't put a lot of questions in your test. You get it? I don't have to give you like 5 different sine graphs to do. I'll be asking you guys to draw these graphs. Obviously, if I give you the equation, can you draw it? I need to see that skill, that ability for you to draw the graph. Secondly, I'll draw the graph for you. And after drawing the graph for you like this, can you work out the information that is missing? Like right now, we want to work out the period of f of x. Do we all remember what we mean by period?
Yes, sir.
Okay, can somebody explain clearly what we mean by period? Yes.
The period of the graph is basically how long it takes for the graph to repeat itself.
Correct. The period of the graph is how long the graph takes to repeat itself. And in other words, we're asking ourselves, after how many degrees does this graph repeat itself? The starting point is for you guys to know the shape of the original basic graphs. Like the graph of sine, I think you all know by now that the graph of sine will look like that. Okay? So this is x here, and that is 1. How many degrees is here?
0.
So that's 0 degrees. And how many degrees is it at the turning point? 90 degrees. And what is that? 180.
270.
Then 270.
360.
And then 360. And what is the maximum value that the graph of sine can take? That is 1. And the minimum is negative 1. So you will need to start there. The graph of sine looks like that. If you want to continue drawing the graph of sine, you will notice that you are actually repeating this pattern. This is the same shape that continues. Like if you were to continue here. Okay, let me do this. This will actually be the same thing repeating. It's a wave, so it keeps on repeating. It will repeat to the right, oops, and also repeat to the left. But if it starts here, and it ends there, and it starts there, and it ends there, how many degrees do you think this one is? 720 degrees. So the graph of sine is repeating after every 360 degrees. Okay. So I think the best thing is for you to know the general shape of a complete period for sine. It looks like that for sine. But you could get a graph that is like this, and I call that the graph of sine. Do you agree?
Yes.
I've just removed a portion of it. What fraction of the portion have I removed?
360.
Like how many degrees did I cut off?
90.
If this was the turning point.
90.
Do you see that I've cut off 90 degrees? There's a turning point there. If I cut this off again, I've cut off another 90 degrees. So what you see there is still sine, right? That is still the graph of sine. But you can tell that is actually half of a period because 2 quarters have been removed. So I like grouping or dividing the graph of sine into 4. So this is the first quarter, up to there that will be the second quarter, this is the third quarter, and that is the fourth quarter. Just in case you find something is missing, because in most cases, you'll find something missing, like that 90 degrees is missing, and they tell you that is the graph of sine. You can still determine the period. All right, so let's look at this question and see if we can answer it now. We want to know the period of the function f.
So you asked the period, sir?
Yes, well, we want the period of this graph. Yes.
The period 180, sir.
180 degrees. Do you see that? Okay, you can start anywhere. Like if you start here, then this graph goes like this. It's a full cycle when you get that kind of shape, right? And this is 0 degrees and that is 180 degrees. Therefore, this graph is a period of 180 degrees.
Yeah, number 3.
Now let's go to number 2. It says write down the range of gx. Remember the range of gx should be made up of it's all the values of y from the minimum up to the maximum. Negative 1 up to 1.
Yes.
Okay, and you can write it like this. Or you can write it like this. I need a strategy, guys, for finding theta. Where did that point 0 degrees and 1 move to?
So that moved negative to negative 45.
So remember, guys, this is a turning point here. We know we did not draw that, but there is a turning point there at 0 degrees and 1. Now, where is the turning point for this one?
Negative 45.
Negative 45, right? So this thing moves to negative 45 degrees and 1. That's a shift to the left. So what does that make theta equal to?
35.
So theta should be equal to positive 35. You don't even have to write this. So theta is equal to 45 degrees. And why we want it equal to 45 degrees is so that if we come here to substitute, we will get something like cosine of x plus 45. And we know that if it's x plus 45, it means we are shifting to the left. And the way we're doing this thing, we are saying initially our graph was here. So that point moves to there, which is shifting 45 degrees to the left. So if you want, you can actually draw that. I'm not sure how. You can draw that graph, the graph of cosine, and then take note of that point. So this point is now moving here. So it's like your original graph is shifting 45 degrees to the left. And so that makes theta equal to 45 degrees. Somebody please explain how we find A. We obviously should use the graph of f. If y is equal to sine of bx, then the period is given by this formula 360 degrees over p. All right, so to find A, what did we say the period was? 180. So we said the period was 180 degrees. But how do we work out period? We say 360 divided by A, right? So 360 divided by A should give us the period. But looking at this graph, the period is 180 degrees.
So what happened to B?
Because they said A, don't worry. Now they said A, they could have said B, it's fine. Whatever letter they use. Okay guys, so first of all, the period of the given graph here is 180 degrees. But the method for finding period for sine is always 360 over p. In other words, 360 over the coefficient of x. In this case, the coefficient of x is a. So 360 over a is equal to 180 degrees. So what is A equal to?
2.
So A is equal to 2. All right. Calculate the value of G of 180 degrees. That's a good question. What do we mean G of 180 degrees?
X is equal to 180.
That means we go to function G, and wherever there is X, what do we put? 180. Okay, so if you do that, so G of 180 degrees should be equal to cosine of, you said 180, right? Plus 45. Okay, which is the cosine of 225, and you can use your calculator. What's the answer?
Negative.
Yes, guys, why do we expect the answer to be negative? It's negative?
Yeah,
Yes.
it's
Yeah, we're waiting for you to repeat. What's the answer?
Negative 0.71, right? Correct. Right, these questions, let's start with the first one. It says, for which values of x will f of x minus g of x be greater than 0? What does that mean?
It has to be
the values of X.
Can someone explain that? Yes.
It means that AFX is above GX.
Okay. It means f of x is above gx. Yes, that is what it means. It means the graph of f should be above the graph of g, especially if you do this, guys. If you rearrange this, take g of x to the other side. We're moving this one to the other side. What do we get?
Positive.
F of x is bigger than
G.
gx. So now I think it's simpler, right? So we are looking for values of x where the graph of f is bigger than the graph of g. In other words, where is the graph of f above the graph of g? Right. So look at this graph. So we are saying f of x minus g of x is greater than 0. It means the same thing as f of x is greater than g of x. And this means f is above g. Where is f above g?
Yeah, 25 degrees.
Which one is f?
That
Okay.
one there, that
I'll make it green wherever it's above. Do you agree it's above here?
Yes.
Yes.
Right. Where else is it above? Now it's below here, right?
At the other side.
And now it's above here, right?
Yes.
Up to here. Is it up to here?
Yeah.
Okay. So this graph of f is above. Is there another place?
Yeah. Yes, sir. The other side.
Oh, okay. Here.
Yes, sir.
All right. Now, can you write down the answers now for which values of x? Which values of x should we be using so that we get a situation like this?
How?
Minus 180 to
That's 3.3 degrees.
oh,
Huh?
Oh,
Oh.
that's it.
Thank you.
Minus,
Okay, let's do this one first. What would you say about x here?
minus 80 to
Or we want to use this method? Okay, that's fine. So x is an element of
minus 180 to minus 90.
from negative 180 degrees up to,
Negative 90 degrees.
I'm not sure what this one, we are told what this one is.
Is one.
That's going to be minus 103.3 degrees. Do you see that?
Oh,
Yes.
sorry.
So it's,
Okay.
all right?
Do we write that down?
Yes, so it's up to negative 103.3 degrees. What kind of bracket do I use there?
Excluding.
Excluding, so it's an open bracket, right? Are you happy with this part?
Yeah, can we do the rest before?
Okay. What about this one?
Dang.
Now you need to think about that point. Do you think that point is related to this point?
Yes. It's just.
In terms of symmetry, yeah, they are related.